Hi, from Gabriele of Staticalmo, the statistical consulting service that helps your small company or organization to reach more rigorous decisions thanks to various domains of statistics. Today I want to show you another case of a survey where the person tells we have 50 respondents that in this case come from the healthcare industry, and the core question deals with the propensity to buy a new software application, and in order to do so they also collected data that we can call socio-demographic data, age range, geographic region, then if they have cryptocurrency investment and so on. Basically the person wants to find some insights with this part of survey, and in order to do so I will use a free software that uses Python as engine. Here you see the answers, and especially this column surprised me because once you have already a score, why also add a free text column that contains something that becomes also more difficult to analyze. And in order to analyze this column that contains natural language, I had different ideas. The first one was topic modeling, that is a natural language processing tool, and another idea is the sentiment analysis, that is more practical. Here we are inside Orange, the drag and drop software that allows us to do different kind of analysis, even if some are too elementary for some aims. And first of all I uploaded, of course, the Excel transformed as CSV, otherwise I can't use this kind of function to load it. Then I selected the explanation column that contained the open answer. I transformed it into a corpus because otherwise I can't do the sentiment analysis. The sentiment analysis gives us 4 columns. We have one column that indicates the positive sentiment, one for negative and one for neutral, and I will select just the compound because it has a positive and negative domain. Instead, the other ones have just a positive domain. After I got this column of data that interested me, because I think, so this is an hypothesis, that this column could explain the score. After I got this column, I merged the column I created with the actual data. You see that I created this link. And so this is the final data without the explanation column, but only the compound column. At this point I select the variables I think are relevant for the analysis, and I start to do some things. For example, the distributions. And you can see this as a graphical way to understand significant variables for our target variable, that is score. So for example, in this case you see the score split by the geographic region. You can notice that more or less we have the same distribution except Rocky Mountains. We can do the same for gender identity, and in this case we see different distributions. Number of kids, again we see something significant, graphically speaking, I want to underline this. Then cryptocurrency investment, we have no split between these distributions. Pet owner, we see dramatic differences. Crowdfunding, almost the same. Work industry, of course, it has no sense because we have just one modality for this variable, this one, but I anticipated it at the beginning. With this exploration we can already have some ideas of significant variables that explain our score. we can do also another kind of exploratory data analysis, graphical, and it is with the box plot. Here we select the score, here the subgroup, and we see that we have a different range also in terms of mean and median, but this difference is not significant because you see that we have a p-value higher than 0.05 and we want something lower. This is an interesting visualization tool I found inside Orange because it also has the annotate function that other libraries, especially for R, they don't have. So as you can see, especially if you saw other videos I did, I'm not a maximalist of R, I just prefer it. So when I see positive sides of implementations of Python, I say it. I don't do the maximalist. We can select other subgroups, and in this case, again, no significance. Number of kids, again, no significance. But you can notice that this is higher than this one, and also this one. Pet owner, we can't have the significativity, and here it is too high for having a significativity. So as you can see, this kind of exploratory data analysis gives us different, let's say, hints than the distribution data analysis. If we directly go to build a model with all those variables selected, we can use something that I don't use because it's not in my approach, and that is something that computer scientists used to use, and that is future importance. You will see that we have the geographic region as the most important variable, and I want to remind you, unless this is the first video of me that you see, that statisticians like me use significativity, so inferential statistics, to decide this and to do variable selection, unless we deal with very specific datasets, but this is another topic. As you can see from this graph, we could discard the last four variables, especially because working industry has zero variance, so it doesn't even have sense to put it as explanatory variable. But on Orange, we can use a way to decide which variables to put inside the model before doing the model, and it is not based on significativity, for example, on correlations, but on rankings. Here you see it uses a method I never heard in all honesty, and we see that we have I would say 4 variables we could select, and if we check this against the future importance, you see that more or less they agree. So the 2 models I built unfortunately have 2 kinds of future importance, and this is another reason why I don't use it. It is a purely descriptive metric that depends on the model. That is not the case for the significativity of the correlations, for example. So this is for the linear model, and this is for the neural network. You see that, for example, here we have this in the first position, and for the neural network it comes as second. As you can see, the order change. And you also notice that the column I created, that is the compound that comes from the sentiment analysis, is useless in both cases, but also in the ranking. After this, we know that the linear regression explains 72% of the variability of the score variable, that is our target variable, and the neural network explains too much, almost 100%. But this is the R squared, and the problem is that here they don't provide also the adjusted R squared, and the R squared has the property that the more variables you add, and the more it increases, no matter if they are significant variables or not. So if we just put the variables that here ranks in the top places, and also the ones that here explain the most, we can create new models. And In this case, we explain less, but if you look closely, you see that we explain almost the same, but with much less variables. So of course, those are models to prefer. In the first case, we lose 6 points, and the other case, we lose almost 40 points. But consider also that this is also at too high value, and that is something that we call overfit. You might wonder why the neural network has a higher score in terms of explaining the score variable, and that is, in my understanding, because the neural network can manage better and in a autonomous way the interaction between variables. If you ever saw images of how a neural network work, you will understand it immediately. Instead, in linear regression, you have to specify the interactions between variables. Let's go to see the future importance for the model built with less variables. And again, you see that more or less they agree, but not so much on the order. Because of course, the future importance depends also on the estimator of the model. Here we have completely different estimators, so of course this descriptive metric is different. To conclude, we have satisfying accuracy for the model that explain the score, but this is based just on a subset of the survey. As a conclusion, I want to underline again that some tools I used inside this Orange workflow are not the ones I use usually. Because as I said in the beginning, this program Orange is very easy to use. In fact, they built it also for kids, but it has some limitations. If this video inspired you an analysis or a survey you conducted inside your company or for your customers, you can contact me, and most likely we will have fun working together. This is all for today. Bye, and see you the next time.